Okay, let's try some questions based on average speed, which has formula total distance covered divided by total time taken, and average velocity, which has formula total displacement upon total time taken. So first question is, an object travels 16 meter in 4 seconds and then another 16 meter in 2 seconds. What is the average speed of the object? So here, let's suppose there is a point A and object cover 16 meter and reach to the point B in 4 seconds. And from B to C, object cover another 16 meter in 2 seconds. Now, the average speed I need to determine. Total distance travel is 16 plus 16, 32 meter. Total time is going to be 4 plus 2, it means 6 seconds. Now, average speed formula is total distance divided by total time. So, in this case, total distance divided by total time. 32 divided by 6, 5.33 meter per second. So, that would be the answer. Next. USA swim in a 90-meter long pool. She cover 180 meter in 1 minute by swimming from one end to the other end and back along the same straight path. Find the average speed and average velocity of USA. USA swims from point A to point B, which is 90 meter apart, and complete its journey in 1 minute. Now, overall distance covered by USA is 180 meter and overall time is 1 minute. So now the total distance is 180 meter and total displacement in this case is 0 because obviously initial point and final point is same. Total time is 1 minute or else 60 seconds. So now average speed is going to be total distance divided by total time. So in this case, average speed would be 180 divided by 60. So average speed value is going to be 3 meter per second. And since displacement is 0, so average velocity is 0. Next question. The odometer of a car read 2000 km at the start of a trip and 2400 km at the end of the trip. If the trip took 8 hours, calculate the average speed of the car in kilometer per hour and meter per second. So we start our journey and starting reading is 2000 km. So odometer has reading 2000 km. After the completion of trip, it shows 2400 km in 8 hours. So overall distance is going to be 2400 minus 200, right? 2400 minus 2000. So distance is going to be 400 kilometer. Time taken we already have. So average speed is going to be total distance divided by total time, 50 kilometer per hour. Now we need to convert this in meter per second also. So for this, I am multiplying it by 5 upon 18. Okay. Or else 1000 upon 3600. Anything you can do. And eventually you will get the result as 13.9 meter per second. Okay. Abdul, while driving to school, compute the average speed for his trip to be 20 km per hour. On his return trip, along the same route, there is less traffic and the average speed is 40 km per hour. What is the average speed for Abdul's trip? Okay. So let's say Abdul start from his home to his school. Okay. And distance between them, I am supposing X kilometer. And cover this journey with average speed 20 km per hour. Okay. And while returning, due to less traffic, he cover average speed with 40 kilometer per hour. Okay. In both way, he cover the same distance. Okay. Now average speed I need to determine. Distance cover is going to be x plus x 2x. And both speed are 20 kilometer per hour and 40 kilometer per hour respectively. Average speed I need to determine. Formula is total distance upon total time. This time total distance is already given, but total time is not. So time taken in forward trip. So we already know time taken would be distance upon speed. So T1 is going to be x upon 20 hours, while in the same manner T2, or you can say return trip time, is going to be x upon 40. So now I have T1 and T2 both. So total time is going to be T1 plus T2, or else this one. Once you solve this a little bit, you will get 3x upon 40. So average speed has this formula. Write down the value. So distance upon time taken, and you will get, after solving this, the value is 26.67 kilometer per hour. So here the question is saying an object moves with speed v1 for time t1 and with speed v2 for time t2. Then find average speed. Okay. So there is an object which cover a certain distance with speed v1 and time taken is given to me as t1. Okay. So let's say there is an object which cover distance, let's say A to B, and speed is v1, time is t1. And from B to C, speed is v2, time is t2. We need to determine average speed. So for average speed, what we need? Total distance and total time. This time, since total distance is not given to me, so I am supposing it as d1 and d2. So total distance is d1 plus d2 and total time is t1 plus t2, which is given to me, right? Now, I am observing the journey from A to B. So if you closely observe, you can use this formula, speed equals to distance upon time. From A to B, my speed is given as v1, distance I let as d1, and time taken is given to me as t1. So the value of d1 is going to be v1 into t1. Similarly, if you consider journey from B to C, you can use the same formula. Speed is equal to distance over time. Speed this time is v2, distance is d2, and time is t2. So the value of d2 is going to be v2 into t2. Now the value of d1 and d2 I am replacing here. So eventually the average speed is going to be v1 t1 plus v2 t2 upon v1 upon t1 plus t2 upon t1 plus t2. So that would be your answer. On your screen, an object move x1 distance with speed v1 and x2 distance with speed v2. Then find average speed of the total journey. Okay. So this time speed and distance is mentioned, but not the time wala part, right? So here I am assuming the object move from A to B with speed v1 and distance covered is x1. And from B to C, speed is v2, distance covered is x2. Since time is not mentioned, so I am assuming it as t1 and t2. Now I need to determine average speed. So for B average, the formula is total distance upon total time. This time distance is given as x1 plus x2, but total time is not given, that I let as t1 and t2. Now from A to B. So from A to B, I can again use the formula speed is equal to distance upon time. Speed is v1, distance is x1, and time I let as t1. So the value of t1 is going to be x1 upon v1. Similarly, if you consider B to C journey, again you can use speed is equal to distance upon time. Speed is v2, distance is x2, time is t2. So the value of t2 is going to be x2 upon v2. So we have both t1 and t2. We can use this value here, and eventually the average speed is going to be x1 plus x2 whole divided by x1 upon v1 plus x2 upon v2. So that would be the average value of the entire journey. Okay. Now consider these two cases, which is very much important. Let's suppose there is an object which cover distance in equal time interval. Okay. So I am considering 3 point A, B, C. Object move from A to B with speed v1 and from B to C with speed v2, and the time taken is same from A to B and B to C. So in this case, you can directly write average speed formula as v1 plus v2 upon 2 using this one. Okay. Let's say if you increase this to 3 points, for example, A, B, C, and D, and this speed is v3 and time taken is again t. So this time the new average velocity is going to be v1 plus v2 plus v3 upon 3. So if you perform the same operation up to n turn, so the average speed is going to be v1 plus v2 plus v3 plus dot 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 and so on till bn divided by n. So in case of same time, you can use this formula directly. Now what about if distance are same? Okay. Let's say I traveled A to B and B to C, and this time taken is different, T1 and T2, but distance is same. Okay, distance is same. Now let's consider another case in which I cover same distance. Okay, so from A to B and B to C, the distance is same, x, speed is v1 and v2, and again time taken is also different. So I can use this formula directly here. So if I put or use this formula in this case, so directly I can write average value of velocity as n. N means in this case n value is going to be 2 and 1 upon v1 plus 1 upon v2. Let's suppose if you follow this journey for the point D also. So you cover A to B, B to C, and C to D distance as x, and speed is v3. So this time your average velocity is going to be 1 upon v1 plus 1 upon v2 plus 1 upon v3, and from here you will write 3. So that's how directly you can use these two formula, and it is very much useful. This question is asked in IIT 2023. A vehicle travel a 4 kilometer distance with speed 3 kilometer per hour and another 4 kilometer with speed 5 kilometer per hour. Then its average speed is, and your option is given these. Now, overall average speed I need to determine, right? So in this question, from A to B and B to C. So initial 4 kilometer is covered with speed 3 kilometer per hour, and another 4 kilometer is covered with speed 5 kilometer per hour, and average speed is they were asking. So no problem. I can use the direct formula that just now I had discussed. So in this case, the average velocity is going to be 2 upon 1 upon v1, which is 3, plus 1 upon v2, which is 5. So if you solve this a little bit, you will get 5 3s are 15 as a LCM. 3 5s are 15 plus 5 3s are 15. multiply 15 with 2, so 30 upon 8, or else if you divide them by 2, 15 upon 4, or if you cancel it, you will get 3.75, which is your option D. So option D is the correct answer. Next question. This question also being asked in the year of 2023. An object moves with speed v1, v2 and v3 along a line segment A, B, B, C and CD respectively as shown in the figure, where AB is equal to BC and AD is equal to 3 times of AB. Then average speed of the object will be, and these are the 4 options. Okay, so let's try this. So in this question, they had already told us that AB and BC is equal. So if I let this distance as x, so BC is also going to be x. Now, AD is 3 times of AB. Okay. So AB is x. AD is 3 times of AB. And I already supposed AB as x. So AD must be 3x. By this method, I am sure the length of CD would be x. So this time the distance is same. Speed is v1, v2 and v3. So directly I can use the concept that I just now discussed. So in this case, the average value of speed is going to be 3 upon 1 upon v1 plus 1 upon v2 plus 1 upon v3. Okay, so if you solve this a little bit, you will get your option B as a correct answer. You can try at your own now. In 1 second, a particle goes from point A to point B. Okay, so here this is my point A, this is my point B. Moving in a semicircle of radius 1 meter. See figure. The magnitude of average velocity is. Okay, so average velocity I need to determine. This is my point A, this is my point B. Okay, so now in 1 second, object reach from point A to point B, and average velocity they were asking. So for average velocity, I need displacement or else total displacement upon total time. So in this case, displacement is going to be this one, right? Which is obviously 2 meter because it is diameter of a semicircle and semicircle has radius 1 meter. So overall displacement is 2 meter and this part is covered in 1 second. So total displacement divided by total time. So average velocity is going to be 2 meter per second. So find average velocity in the given case if body travel as shown in the figure. So initially body goes with speed 20 meter per second and travel for 10 seconds. And for rest journey is covered with speed 30 meter per second and time taken is 20 seconds. So this time I need to use, this time I have to tell average velocity. So average velocity has formula total displacement upon total time. But this time total displacement is not given to me. So I am supposing from A to B, the displacement covered is x1 and from B to C, the displacement cover is x2. So total displacement is x1 plus x2. Total time is 10 plus 20. Okay. Now, I am considering journey A to B. So from A to B, I can again use speed is equal to distance upon time. Speed is given to me as 20. Distance I let as x1 and time is 10 seconds. So the value of x1 is going to be 20 into 10 or else 200. And in the same manner, if you consider B to C journey, again I can use speed is equal to distance upon time. Speed is 30 meter per second. Distance I am supposing x2 and time is 20 seconds this time. So x2 value is going to be 600. So average velocity value is going to be total displacement x1 plus x2. So my x1 value is 200 and x2 value is 600 and total time is 10 plus 20, 30. So it is going to be 800 divided by 30. 0 and 0 I can cancel out. So 80 upon 3 meter per second is going to be the answer. Car moves a distance of 400 meter. It covers first half of the distance with speed 30 meter per second, second half of the distance with speed b. If the average speed is 20 meter per second, find the value of b. And four option is already given. So object need to cover 400 meter distance. Okay. A to B and B to C. First half, which means 200 meter distance, is covered with velocity 30 meter per second, and rest distance, it means 200 meter, is being covered with speed v. Average speed is given as 20 meter per second, and the value of b I need to determine. Okay, sir. So what can we do in this case? Not a big deal. So I am determining or using the formula of average velocity. Okay. So the average velocity is total distance upon total time. So total distance is 400 meter, 200 plus 200. Total time I am assuming as T1 and T2. So total time is T1 plus T2. This time average speed is given to me as 20. So this value is 20 equals to 400. But time is not given. Okay. So T1 plus T2. So to determine time, again I am considering the journey of A to B here. A to B. So from A to B, I am using the formula speed is equal to distance upon time. Speed is 30, distance is 200, and time I am supposing as T1. So T1 value is going to be 200 divided by 30 or else 20 upon 3. In the same manner, T2 value is 200 upon V. Okay. So this value you can use here. So 20 equals to 400. The value of T1 is 20 upon 3 plus value of T2 is 200 upon V. Now let's solve this case. So 0 and 0 get cancelled. By 2, this get cancelled 20 times. So here you will get 1. Now do cross multiplication. So 20 upon 3 plus 200 upon V equal to 20. Okay, so let's solve it. So 200 upon V equal to 20 minus 20 upon 3. So if you solve this, you will get 60 minus 20, 40 upon 3. So by this 0 get cancelled, and by the 4, 20 get cancelled 5 times. So 5 into 3, 15. So 15 meter per second is the value of B. So your option B is correct. A body covers first 1/3 of the distance with velocity 10 meter per second in same direction. In second 1/3 with velocity 20 meter per second, and last 1/3 with velocity of 30 meter per second. The average velocity of the body I need to determine. Okay. So in this time, I am assuming the body has covered overall 3D distance. Okay. Overall 3D distance from A to B, B to C, and C to D. So this distance is D, this is D, this is D. So according to the question, first 1/3 distance is covered with velocity 10 meter per second, another 20 meter per second, and last 30 meter per second. So this time distance is same, so we can use our trick. So trick says average speed in this case is going to be this way. B average is going to be 3 upon 1 upon 10 plus 1 upon 20 plus 1 upon 30. Since distance is same, so we can use this technique. LCM of 10, 20 and 30 is going to be 60. 10 6 ja, 60, 23 is a 60, 32 is a 60. You can multiply this. So 3 into 60 upon 6 plus 3, 9, 9 plus 2, 11. So 180 divided by 11. So if you divide this, you will get 11 1 ja 11, carry 7, so 70, 11 6 ja 66. So 16.4. Option B is going to be the correct answer. Question is asking a body travel with speed of 60 meter per second for half distance and the remaining half distance for half time speed was 20 meter per second and for remaining half time its speed was 40 meter per second. So this is really a good question. I want first you pause the video and then try to solve it. Scenario is body move from A to B and cover distance D and having speed 60 meter per second. From B to D, it cover two distance with same time, T and T. So from B to C, it goes with speed 20 meter per second. And let's suppose distance covered is D1. And from C to D, distance is D2, speed is 40 meter per second, and time is same T as given. The value of D1 plus D2 must be D. Now we need to determine average speed. So for average speed, we need total distance. So in this case, total distance is D plus D, 2D, and total time. So from A to B, time taken is D upon 60, distance upon speed. From B to C, time taken is D1 upon 20, and from C to D, time taken is D2 upon 40. Now let's solve. So from B to C, the value of time is speed into distance, right? From B to C, now by the formula, speed is equal to distance upon time. If you consider B to C, speed is 20, distance is D1, and time is T. So the value of T is going to be D1 upon 20 from B to C. Now let's talk about C to D. The speed is 40, distance is D2, and time is T. So the value of T is going to be D2 upon 40. So I can compare these two and I am getting D1 upon 20 equal to D2 upon 40. 21s are 20, 22s are 40. So if you cross multiply, you will get D2 value as 2 times of D1. Now we know D1 plus D2 equal to D. So D1 remain as it is and D2 value I am getting as 2D1 equals to D, or else 3 times of D1 equal to D. The value of D1 is going to be D by 3. And since I have D1 value, so D2 value is also going to be this time 2D by 3. So the value of D1 and D2 I am replacing here. Now my average speed is going to be 2D upon D upon 60 plus D1 is D by 3 and 20 is already there. D2 is 2D by 3 and 40 is already there. So by this 2, I can cancel this 40 20 times. So B average this time is going to be 2D upon D upon 60 plus D upon 60 plus D upon 60. Or I can write this as 3 times of D upon 60. D and D got cancelled. I need to multiply this with 2. So 2 into 60 divided by 3, 20 into 2. 40 meter per second is going to be the average speed for this question. Next, a particle is moving such that its position coordinate x and y are 2 meter, 3 meter at time t is equal to 0, 6 meter, 7 meter at time t is equal to 2 seconds, and 13 meter, 14 meter at time t is equal to 5 seconds. The average velocity vector from t is equal to 0 to t is equal to 5 seconds we need to determine. It is very easy question. So particle starts from 2, 3 and it ends with 13, 14 and overall time taken is 5 seconds. So we need to determine average velocity. So for average velocity, first we need displacement. So in this case, the particle moves 13 minus 2, 11 meter in x direction and 14 minus 3, 11 meter in y direction. So in vector form, you can write your displacement vector as 11i plus 11j. Overall time taken is 5 seconds. So V average or average velocity vector is going to be 11i plus 11j whole divided by 5, total displacement upon total time. You can bring 11 as a common. So I plus j upon 5. So option D is the correct answer. The question is, position of a particle change with time as this. Find the magnitude of the following. Velocity at t is equal to 5 seconds, average velocity in first 5 seconds. So this is going to be the question. Now let's try to solve it. So first part is very much easy. Position is given and velocity is asking. So we already know if we have position and velocity we need to determine, we differentiate. Velocity is dx upon dt. Change in displacement upon change in time. So let's calculate dx upon dt. So x is already given to me as 2t square plus 3t plus 4. Now I am calculating dx upon dt. So dx upon dt value is going to be 2 times of the differentiation of t square is 2t plus 3 differentiation of t is 1 plus differentiation of constant part is 0. So dx upon dt value is going to be 4t plus 3. 4t plus 3. dx upon dt is velocity. So velocity is 4t plus 3. Now the time is given to me as 5 seconds. So velocity at t equal to 5 seconds I need to determine. So 4 into 5 plus 3. 4 5 the 20, 20 plus 3, 23. So 23 meter per second. So that would be the velocity. So this is going to be the first part answer. Average velocity. So for average velocity, in first 5 seconds, we use this formula 0 to 5 x dt whole divided by 0 to 5 dt. Okay, so this is going to be the formula for average velocity. Average velocity. Now, let's solve this. So 0 to 5, the value of x is given as 2t square plus 3t plus 4. And it needs to be integrated. In the denominator, we have only dt. So if you integrate dt, you will get t. And limit here is 0 to 5 seconds. Okay. Now integrate 2t square. So t square will have integration t q upon 3. 3. T has integration t square upon 2 and integration of 4 is 4t. 0 to 5. In the denominator, if you put limit, you will get 5 minus 0. So using limit, I am getting 2, 5 raised to the power 3 upon 3 plus 3, 5 raised to the power 2 upon 2 plus 4 into 5. And if you put limit as 0, eventually you will get result as 0, whole divided by 5. So you can take common 5 and it gets eliminated by the denominator. So 2 into 5 square. 5 square is 25 upon 3 plus 3 5s are 15 upon 2 plus 4. You can assume 1 in the denominator. LCM of 3 and 2 is 6. 3 2s are 6. 2 2s are 4. 2 is 4 into 25. 2 3s are 6. 15 3s are 45. 1 6 is 6. 6 4 is 24. 25 into 4 is 100 plus 45 plus 24 whole divided by 6. So eventually I am getting the result as 169 upon 6. So that would be the answer. Okay.